Okay, welcome to another lecture. We will continue from where we left off last lecture. So last lecture, we introduced our runtime environment Node, which will allow us to run JavaScript at the OS level. We I think spent most of our lecture discussing the basic architecture of the Node JavaScript runtime environment. So in this lecture, I kind of just want to follow up with the core modules, or what we can consider the standard library on Node. And then I want to do an introduction to NPM, the Node package manager, and just do essentially a quick overview of those two things to a degree that you'll feel comfortable being able to have an understanding of what both Node will supply to you in terms of what built-in objects, built-in methods, and built-in libraries, essentially, that you can depend on, and also an understanding of what NPM provides to you in terms of your workflow for developing back-end applications. Okay, that said, let's hop on over to the slides. Okay, so the first thing that I want to discuss, these two concepts, is going to be the Node core modules, which again we can think of as the standard library, which are going to be those modules that are installed alongside Node that we don't have to install externally. So these will always be provided to us for every application. We can import them to any one of our JavaScript applications, backend applications, without having to go ahead and install them as a module using NPM. Okay, so as I might have stated earlier, I think last class, but I'll reiterate for this lecture as well. In Node, modules are blocks of encapsulated code that communicate with some external application on the basis of their related functionality. So a module can be a single file, or it can be a collection of multiple files or folders. And of course, the reason that we as developers heavily rely on modules is because of the reusability, as well as the ability for us to be able to break our code base down into much smaller chunks. And so typically, when we start developing our code base, there are three types of modules that we can come across. There'll be the core modules, which ultimately represent the standard library for Node. And so this would be equivalent from front-end development on the browser-based methods and functions and objects that were provided to us. So the browser object model and the document object model. So here we'll have the core modules. And then you have local modules, which are those that we can install, or that we define ourselves. And then third-party modules are ones that we can install using the Node package manager. So these are typically going to be the three types of dependencies that we can go ahead and import to build out our applications. Okay, so in terms of the core modules, Node has many built-in modules. I'm going to give you a full listing in just a moment. The basic idea on how we can use these modules, though, is going to be the syntax that I covered last class. We're going to use the require keyword. So we would go ahead and typically when we go and import, we already know how imports and exports work. So typically we're importing some object or some function or some type of data from an external script or module, however you want to think of it. And then we can bind that to a variable inside of our into our local module, into our local application file. And so the require function will return a JavaScript type depending on what the particular module returns. So this following example just demonstrates how this might work. Nope, this is not how we use the HTTP. Let me get rid of that. Okay, so let's first start with a very comprehensive list of every core module and a quick description of what it includes inside of Node. And so here, the intent of this slide is just to give you a quick understanding of everything that's already provided to you. I'm going to pair it with just a sentence. I will not go into significant detail on most of these modules, but I think it's important that you understand that they exist so that as you start to develop your own full stack application, if you come across one of these requirements, you know to go ahead and check the Node API to get more details on these modules. So I'll read these out just very briefly. So we'll have an assert module, and essentially what the assert module is really designed to do is to provide a set of assertion functions that's useful for testing. So you're probably pretty useful for what assert methods are used for from JUnit testing. And so the incentive here is for very similar capability for you to be able to do backend testing on your Node scripts. The buffer module provides the ability to handle buffers containing binary data. We mentioned what a buffer was last lecture, so here we can see that there's a built-in module to go ahead and handle that. Child process provides the ability to spawn child processes. Recall that Node itself is a single, it handles things as if it were a single threaded application. And so it is often useful to be able to spawn multiple threads to be able to handle things outside of your main thread. The console module provides a simple debugging console. We looked at a lot of those methods last lecture. The cluster module allows you to split a process into multiple workers, which essentially can execute on separate threads. And this is really to benefit from any kind of multi-core system you have. There's a crypto module that provides cryptographic functionality. You have the dgram module, which provides an implementation for datagram sockets. So this is essentially a networking protocol. So it's a layer of packaging our data, one layer underneath their application layer. And so if you're not familiar with datagrams, then this is certainly a concept that you will cover in more detail in networking, but one that will, for all practical purposes, not really be critical to this class. You have the DNS module, which will provide a name resolution for domain name lookups. You have the events module, which I believe we covered a little bit last lecture, but I'll go into more detail this lecture about the events module because I think this is one that is worth knowing more intimately. But this provides an API for managing events. And recall that Node, just like the browser, is essentially event-driven. The FS module, that's short for file system, provides an API for interacting with the file system. So whereas we were typically reliant in the browser to interface with the document object, here, most often, when you're operating at the OS level, you're typically interfacing more with files in the file system. So this is typically something that's guarded away from you from the browser, but this is going to be probably something we'll be utilizing much more of since we'll be treating this as a back-end programming language. And so for that reason, I'll go into more detail on what we can do with FS. And I believe the current lab has you actually using the FS module and some of the functions from it for the lab that's due, I think, this Friday. We have the HTTP module, which provides built-in HTTP client-server implementation. So this is super useful for managing web server stuff. But as we'll see, the overhead for hand-rolling a HTTP server will be simplified when we pivot to a web framework that's called Express. And we'll talk about that either next lecture or the lecture after. They also have an HTTP2 module, which provides an HTTP2 client server implementation. We will just look at this one. We also have one for secure HTTP. We have a net module, which provides an asynchronous network API, and a module for our operating system. We have a module to be able to parse out paths. So we will look more deeply at this path in OS 1.2 in this lecture. The perf hooks enable us to enable the collection of performance metrics. So this is good if you wanted to go ahead and do diagnostics on how your application is running. Again, this would be something that's good for testing, the measures of your application. We have the process module, which we had covered, I think, in pretty good detail last lecture, so I'm not going to go into much detail this lecture on this, but this provides information about the control over the current node process. So this, if you recall, is our equivalent in Java land to the system object or the system class. You have query string, which provides utilities for parsing and formatting URL query strings. Oh, I should have, I don't think I covered this in this lecture, but this is something that would be worth going through, I think, a little bit more. So I might follow this up on some future lecture, or you might just be able to read the API. As we go through these modules, I think you'll get more and more comfortable seeing how you could just read the API on these. We covered the read line module last time. This allows us to essentially interface reading data from the readable stream. If you recall, essentially Node really relies on streams and buffers for managing the input and output of data into the Node runtime environment, and that is pretty similar to most other interpreters or programming languages. Okay, we have the Rebel. We covered the Rebel last time. Stream, the string decoder essentially allows us to do interesting things with strings. You have timers, which helps interface with the event system as well, but more importantly, it allows us to access the scheduler to be able to schedule callbacks for future times. I'm pretty sure we covered the timers module last lecture while talking about the general architecture of Node, so I don't want to cover that in this lecture. We'll have, just like we have the ability to kind of do interesting things with datagram sockets, we could also do things with TLS, so that's transport layer security, and secure socket layer. Again, we won't probably cover this in depth, but it's good to know that there's a module there, just in case you need it. TTY provides functionality used to perform I/O operations in the text terminal. We will cover this one more in detail, URL, which provides utilities for the URL resolution and parsing. And this should not be dissimilar to the same URL object that we had in the browser. So I just want to correlate to the URL object that we've already covered. util has essentially just some internal APIs that Node relies on, but we could potentially rely on. I'm not going to cover that in much detail. V8, if you recall, is the actual it's the actual JavaScript engine. So we won't go into that much, but this just exposes APIs to the underlining Node JavaScript runtime environment. VM enables compiling and running code within the V8 virtual machine context. Again, we will not look at that. WASI provides an implementation of the WebAssembly system interface specification. A worker allows us to run on a different thread, so this enables the use of threads to execute JavaScript in parallel. Workers are not just something that's available on the back end. We also have web workers available in our browser as well. So we can run essentially concurrency on both the back end and the front end. And then zlib is a module that provides some compression functionality. So, just very kind of briefly, we see everything that you get by default from the Node runtime environment. All these are built in. You don't have to import them. You don't have to install them or download them. They're available as part of the global object. And all you have to do to access these is to import them using the requires keyword. and they are available by default. You don't need to have them in a node modules folder, which you'll be more familiar with as you continue through the first lab. Okay, so let's look at some of the more critical of these modules that are worth understanding some of their methods and properties and classes that they might contain. So the events module, which we covered a little bit last lecture, provides us with that event emitter class, which is of course key to working with events in our backend. So if we wanted to go ahead and create something related to the events system, we could go ahead and use that require keyword and just pass in the string events, and then bind this to some object that we can use locally. So here I just use, let's actually be, yeah, I used event emitter. And so in this instance, what we're going to get back is essentially a constructor. So we can invoke that constructor event emitter and then create an instance of an emitter. And then all the things we can do with the emitter would be similar to how we can manage the event handlers or the event emitters inside the browsers. So like, for instance, we can have an emitter add a listener to it. So add listener is aliased also for on. So both on and add listener do the same thing. And this just adds a callback function that gets called when a particular event is emitted. And so one nice thing about the backend system is we get to declare labels for those events. So it's not like the front end where there's going to be a lot of clicks or other types of events. We can actually name things. Although you could listen for those events. I mean, you could build a backend application that does listen for those user-generated events, but we can create custom events that our application emits into the event dispatcher as well. Okay, let's see. We have the ability for the emitter to emit. So this just emits an event. The event names returns an array of the events that are being listened for. We can also get the max number of listeners that a particular event listener object can have. By default, it's set to 10, but we can actually change that with a method that's called set max listener, which is this one right here. So this allows us to decrease or increase the amount of event listeners that an event listener object can have. We can get the listener count. We can also get back the listener objects as an array. We can remove events using either auth or remove listener, and we can pass it in a particular listener we want to remove. Remember, a listener is just a callback function, so we pass that as a parameter, or we can clear all the events using a remove all listeners method. Now, when an event is added into the event queue, the queue of listeners, we typically, it's done in a as a queue, so first in, first out. But if you want to prioritize an event to be put in front of all the other listeners, you can use prepend listener. And so this operates just like add listener, but it adds it to this particular listener to the front, so it triggers first as opposed to last. Okay, so those are pretty much just a general overview of the methods. And typically, the concept of the way that these methods would interface in an application would not be dissimilar to the way that we use events in the browser side. So, so does everyone, at least covering these methods, have a good feeling about at least what the events modules will provide on the back end of our node code? And for actual more like real practical examples, I'll try to ensure that we get a lab that covers some of these concepts. Although I don't think this lab covers events in any great detail, and I don't think the next one will either. So for the FS module or the file system module, the way that we can access that would be using, again, the required keyword, and we pass in the string fs. And so then we would bind the results of that to some variable that we have available through our local module or through our local script. And here's a detailed, and so just a quick overview of some of the file system methods that are worth knowing. Access lets us know if we have access to a file based off of the file's name. Append file allows us to add data to a file, and if that file doesn't already exist, it will create it. Change mod or chmod or chown are similar to what you'd expect. So this allows you to change the permissions of a file, and this allows you to change the owner or the group of a file. You have the ability to close a file that's been opened so that some other application can lock onto it. So it's important to close files after you're done opening and reading them. Copy files allows us to copy a file. We can create a read stream or create a write stream. Remember, these streams are how we typically communicate data. So this just allows us to, these are just methods that allow us to actually instantiate streams. For the purpose of file writing, link allows us to create a link to a file. We can make a directory. We can make a temporary directory. We can go ahead and open a file. We can read a directory. We can read a file. Let's see here. We can read a link. We can resolve a relative path. We can rename a file or folder with a rename method. We can remove a directory. We can check the stats or the status of a file to give us crucial data. I'm pretty sure we used this one in the most recent lab. We can create a symbolic link. We can truncate a file to a specified length. So we pass in a parameter of how long we'd want that file to be. We can unlink we'll remove a file from a symbolic link. We can change the timestamp on a file, and then we can write to a file. So these are typically the very common file management calls that you can do from either other languages like Python or Java, or if you're in a Bash environment, typically you can do a lot of this stuff at Bash as well. So I just want to illustrate that the file system module in JavaScript's runtime environment Node is as comprehensive as you would anticipate it to be for any other programming environment. And so again, since you have access to your file directory, you can rely on this to be able to create or remove data files on your system. So you do have the ability to create files for any reason. And so one thing that I do want to highlight, besides all these methods here, it's important to understand that every single method inside the file system is asynchronous by default. And I think we mentioned before that there was a focus on the Node runtime environment to be an asynchronous environment. However, you also have the ability for any one of those methods to also operate synchronously. And you could do that just by appending the sync name after the typical method name. So if you want to use rename, but if you didn't want to use it in a promise-based environment where you would have to then pass a callback function that resolves after the promise itself resolves, then you could do rename sync, and that gives you a synchronous version of the rename method. So the default value is asynchronous. The sync version can be labeled just like that. And it's just similar with write or any of these other methods. And so really the only reason why you'd want to use one or the other is based off of the application flow that you're targeting to implement. And to give you just a quick example of how those two might distinguish, suppose here we use the rename method, so that's going to be asynchronous. So here the first thing I'm going to do is I will import the file system module into my local workspace. I will then access the file system with this label that I gave it, right, fs, to invoke the rename method. Now this rename method is asynchronous. And so here, when I rename, I'm going to pass it the name that it is now. So before.json, I will then name it something that I want to call it afterwards. And since this is asynchronous, I'm going to give it a callback function on what to do as it is performing this operation. And in this instance, I don't want it to do anything on a resolution. I just want to do it on something in response to rejection. So on the instance of a rejection, I would get some kind of error object. So if there is an error object, I want to check, is this an error object? If it is, then I want to console log to the error stream that error. Otherwise, I don't want to do anything. So this is just an example of how we can go ahead and use that promise-based implementation, right, for asynchronous execution of renaming. And this is very common, by the way, using some kind of asynchronous or some kind of exception handling whenever you're dealing with anything related to I/O, in addition to networking. And so you're probably familiar with this in Java 2 when you were doing either serialization or when you were doing something related to file reading and writing. So if I want to do the synchronous approach, which is probably what you're familiar with in Java, then I would use a try-catch block. And instead of using rename, I would use rename sync. So here, looking at this block of code, I would import fs, which is my file system, bind it to this variable fs. Then I will try to execute this invocation to rename sync by passing in the file that I want to rename and then the new name that I want to have. And on the instance that some exception or some error object occurs from doing this, then I can catch that and console log that. So effectively, these are doing the same thing. It's just one of them is done using a asynchronous metaphor, where the other is doing a synchronous metaphor, and therefore it requires a try-catch block. Does this concept make sense on how we can? So, I mean, either of these are viable. It just depends on what you're more comfortable dealing with. So if you're getting comfortable dealing with a promise-based model that utilizes callback functions, then you'd use sample A. If you're used to like the more Java-centric model, then you can, at least for the file system, use model B here. Excellent. Okay, so I want to then move on to the OS module. And so the OS module is a module that provides many functions that you can use to retrieve information from the underlying OS and the computer itself. And so here, let me just illustrate. I think this is actually something that shouldn't be hard. That is not what I want to find. Oh, here, it's hidden. I do a new window. Okay, so here, let me see if I can't show you these and talk about them as I actually do them to make it a little bit more interesting, so we're not just looking at slides. So let me launch into Node. So here I'll launch into Node. And so here, let me import that OS. And so here I'll create a variable OS. I'll make it a constant because I don't want it to change once I import it. Here I will import using the require keyword. I will pass a string of what the module name is. It's OS, and semicolons in JavaScript are optional, but for programming practices, I always typically add them. Okay, so now I have OS. So os.arch, that's for architecture. It gives the architecture of our underlying system. os.cpus gives us CPU of the system. Let me see. I don't know if there's an easy clear. Yeah. Okay, well, I'll just keep going with it. Get spoiled with having clear options. Let's see. break, clear. Oh, yeah, I thought there was a clear. I guess there's not. No. Alias for, oh, it just breaks me out. Okay. Okay, let's see here. The Indianness lets me know whether it's little Indian or big Indian. So on my system, it's little Indian. Let's see, I could check for free memory. I can check for the home directory that I'm in currently. So, or not currently, but let's see here. Let's open up. Let's go into desktop. Let's launch Node. Let's see here. Let's const OS is equal to fire OS, and let's see OS dot directory. Yeah, so it just gives you the home directory that you're currently logged into, not the current directory, not that you're working from. The host name that you're currently logged into, the load average. Don't think we'll need to use that, but I guess for testing purposes, if you ever want to see how quickly your system, on average, loads up files, you could use this. This provides your networking interface. Yeah, of the system you're currently on. Platform tells you what platform you're on. Release lets you know what release your OS is. Temporary directory shows you the location of where the temp directory is on your OS. Total memory is the amount of total memory versus free memory. OS type, the type of OS you're on. The uptime is going to be the number of seconds since your system was last rebooted. Oh, Lord, I don't want to know what this is. Okay. And finally, user information provides information about the current user. Anyway, you can see you have lots of interactive information that you can just pull right from the OS module. And you can see, I actually kind of want to run through these as an example of how easy we can access this from a script, or in this instance, the REBL as well. Remember that Node, just like Python, supports a interactive runtime environment that you can experiment and put your statements in and actually see what happens as you execute them on the fly. Okay, let's exit out of this for a moment and move down from the OS module. Okay, so the path module provides a lot of very useful functions to access and interact with the file system. And in this instance, what we mean by the file system is paths that allow us to access directories or files within inside the file system. So actually, why don't we take a look at some of these? So I will do the same thing I did before. Let's clear this, though. And now let's launch Node again. And so once I launch Node, let's get access to this path module. I'm going to access this path module by, again, using this require keyword and passing as a parameter the string of the module I want. And so this is a built-in module, so I don't have to install it. And then right here, I will bind it to the path keyword for the path label identifier. Okay, so there's a couple of methods that are worth knowing here inside of path. So we can get the base name. Oh, first of all, there's a couple of properties. So SEP gives me the segment separator. So this is when we delimit between directories in Windows and Linux, we actually use two different symbols. We use a / for one OS, and we use a / for the other OS. And then for path.delimiter, to delimit, we typically use semicolons in Windows, whereas we use a colons for Linux or Mac OS. So when you have a collection of paths and you want to delimit between them, or state this is where the first one ends, and this is where the second one begins, and this is where the second one ends, and the third one begins, we actually use two symbols, different symbols for that. So it's worth using these properties. So when if you're programmatically implementing something that has to manage with essentially paths, file paths, then it's better to rely on these properties so that regardless of what the underlying OS is, you can specify the delimiters or the pathing, the paths, the delimit between the directories appropriately. And I mean, just to show you that, I'll show you path.sep. Yeah, you see, since I am on a Mac OS, I use a backslash. And the limiter would be colons. Now, if you were to do this on your Windows machine, you would get forward slashes and semicolons. Okay, so the path base name returns the last portion of a path as the first. Returns the last portion of a path, and a second parameter can be used to filter out the file extension. So you could use two parameters, or just one. The dir name returns the directory part of a path. The path.ext name returns the extension part of a path. The path.isAbsolute returns true if it's an absolute path and false if it's a relative path. Path join allows you to join two paths. Path normalize will try to calculate the actual path when it contains relative path symbols such as the period or double periods or double slashes. The path parse will parse a path object into a root, the directory, the base, the name, and the extension. Path relative accepts two paths as arguments and returns the relative path from the first path to the second. And path resolve will resolve the absolute path from a relative path. So I'll actually give you examples of all these. And again, I'm kind of going over all these in great detail during lecture because it's my intent in the labs to actually use these modules. But when I use these modules, I'm going to use them such that I'm only going to use a one or two of the methods at any time. It's hard to build, honestly, a lab that requires us to use all of the FS module or all of the path module or all of the URL module or all of the HTTP module. And so I'm going to go under the principle here that you're going to see the use cases for these in a limited setting by the labs, but you're going to understand that the scope of these modules is far larger than what the lab presents. And so I want you, even if you watch this, watch these lectures. So it's my intent here, not for you to come away and understand all these modules. I just want you to hear what all these modules do so that if you encounter a problem or if you encounter an obstacle that you have to manage in terms of accessing files or reading files or writing to files or accessing paths or using paths to access data from your underlying backend system, the first thing you can think of is, oh, let me investigate the FS module because we briefly covered the scope of what it can do. That's the intent of covering over these concepts. You'll get more practical experience, in my opinion, from the actual labs, but you'll get an understanding of what the scope of these modules are from this lecture. Okay, anyway, with that said, let me show you just some basic examples of some of this in practice. So for instance, and I gave myself some examples here that I can just briefly show you. So here, oh, well, I already grabbed the new line character. So for the base name, notice if I go ahead and pass the path of home/public/index.html, it gives me the base name of the actual file, right? So it separates the directory path from the actual base name, which is the index.html. So in the instance that you need to correlate just this information, that is a great way to be able to do it. Now, if I wanted to take the same thing and get the directory name of that path instead, I can just put dir name, and notice now I get the home/public part. So again, the path module is really very useful for being able to parse a lot of valuable data that you might need for processing from path names. And again, if I just want the extension name from that path, I can just do ext name, short for extension name. And again, that would give me HTML. Then if I want to ask, is this a absolute path or is it a relative path? I can just do is absolute. And this is false. Okay. So what would I have to do for this to actually qualify as an absolute path? What does every absolute path, what must it have if I am on a Linux or Apple system or Mac OS system, a POSIX compliant system? Well, we would need to have a root path included, right? And so root path would always be starting with just the slash, right? And so that is what's going to distinguish for us the difference between an absolute path and a relative path. See, anything else would be relative. So just a name that doesn't start with a root directory, or even obviously if I put a dot or double dots, all these represent relative paths. And then if I want to normalize, I could go ahead and normalize. We'll go ahead and remove the dot or the double dots. If I want to parse a path, I could do path.parse. Please, wait. What happened there? Did not copied a lot of crazy stuff. Okay, stop that. Makes this difficult. I need to reformat this in a way that makes it easier for me to grab my examples. Okay, so if I want to parse the path here, I can, if given a path, find what is the root, what is the directory part, what is the base, what is the extension, and what is the file name itself. So parsing produces an object that has all the properties of what a lot of these individual calls go ahead and provide. Then we have relative. Nope, did not copy that. And perfect. So what relative will do is, if giving a current working directory and some file name that I want to get the relative pathing for, it will go ahead and process this as a result. So it's going to show, oh, the relative path for index.html, if the intended current working directory is app/public, would be //index.html. So this is just a means for generating a relative path for a file, giving some current working directory as your first parameter. And then the last one that I just want to cover inside the path object is the ability to resolve the absolute path from a relative path. So if my relative path is desktop, then it says, oh, well, the absolute path would then be /user/ted/desktop. So again, the intent here to show you a complete scope of what we can do with parsing paths, what we can do with reading and writing to files, what we can do in terms of accessing information relative to the OS as opposed to the process, which we covered last lecture. And so just like we have file paths that your backend server might be concerned about in terms of accessing local files, you also have a URL module to be able to provide a similar type of functionality for parsing the URLs that are provided from request or whatnot. So since this is a web server, pathing can be defined as both one that happens across the internet using URLs, addressing that way, versus pathing across your local OS, in which case you access local files. So it's often the case that your web servers have to be able to process those two different types of paths. And so you also have URLs. And so the nice thing about the URL module is it operates very similar to the browser, to the same URL object that we saw in the browser. So we can go ahead and do URL formats. So we can return a customizable URL string. We can parse a method to get into a URL object. We can use a URL constructor just like we can in the browser. It's exactly the same. I'll give you a quick demo of that. So here, let me actually access the URL module. Actually, let me do this. Let me do dot exit. Let me do clear. Let me do, let's run node and let us do const URL is assigned. We should require, we will require from it URL. Perfect. Okay, so now that we have a URL object, let's go ahead. Oh, no, that's not going to work. I'm missing the new. So from my new URL object, I will access this constructor URL. And so here I will provide 2 arguments just to show that I can provide those 2 arguments. I don't necessarily have to. But in this instance now, you can see the first will become a relative to the origin, which could be the second parameter. If it's just 1, that's going to just build a URL object from that 1. So it's going to give me the href. It's going to give me the origin. It's going to give me the protocol. It's going to give me the host. It's going to give me the host name. And it's going to give me the path name. And if I had, actually, let's go ahead and, I think I'll show an example of this again in just a moment on the next slide. But I can also add in search parameters. I can also add a hash to that, and that would also give me that. And so this is extraordinarily similar to what we've already seen previously. So we can parse URLs and pull from them all the relative data. In fact, we could do the same thing with the URL search params. There's a URL search param object, just as there is in the browser. So if I invoke a new instance of that, notice it creates a URL search params object that gives me the key value pair by parsing that query string or that search parameter string. So again, this is one way that we can transmit data, as we said, between a web client and a web server, and just illustrating that the same parsing object, the same URL object that we can use on the client is the same one we can use on the backend. So I don't want to spend too much time on this because I feel like we've already spent time talking about this, but I do want to illustrate it is available to you on the backend, and we might even use it. It might already be in, you might have already used it in the lab before, and if not, you might probably use it in some future lab. And so the URL module, as you can tell, also contains 2 URL classes or inner classes, in addition to being able to format URL objects or parsing URL objects. And we already kind of saw all these different properties. I'll actually copy and paste this though, so that we can actually see all of the parameters in detail. Let me check my URL. Okay, there we go. So here we can see, yeah, this time I did set a hash right here inside the URL string, and I also have a query string. And my search parameters had actually built that into an object as well. And then, yep, we already covered this. Your URL search parameter object has all the same methods that it does inside the browser. So I didn't spend too much time going into detail on what they do. So essentially allows us to append search parameters to the URL search parameter object, delete We can use the for each method on it, or we can get the keys. We can get the entries, which is the key value pair, or just the values. We can sort them. We can get a value based off of its key. We can check to see if it has a particular key. We can set a key value pair. So again, these are all the same methods we have available to our URL search params as we did in the browser. We also have it in the server or in our Node environment. Okay, so we looked at the URL module. We looked at the path module that allows us to look at addresses as either URL addresses or path addresses for local system or web-based HTTP systems. We looked at the file system module. We looked at the event module. So I think really the last module I really want to cover today, before talking a little bit about the Node package manager, is the HTTP module. And the HTTP module is essentially a core module that gives us Node built-in networking capabilities. And again, this allows us to actually develop web servers very easily by just importing this module. And so this module really includes 3 properties: a methods property, a status codes property, and a global agent property. It has 3 methods, which is going to be a create server method, a request method, and a get method. And then it's going to have 5 classes to support this module. It's going to be an agent class, a client request class, a server class, a server request class, and an incoming message class. So I'll just briefly kind of go over what each of these do. So my HTTP module, again, I would import the same way that I would typically import the rest of these modules. So just use the require keyword, and I would pass in the name of my module as a string, and then bind that to some variable. And once I do that, I can access all the properties, all the methods, and all of my classes. And of course, I can use the destructuring if I wanted to access other things. This is just one way that I can access them. You could use any way to import a module that we already learned about, to be able to just dereference a attribute that's provided from this this export object. Okay, so let's talk about the properties that HTTP module has. The HTTP methods is it lists all the HTTP methods that it supports. In fact, let's see if I can't do this. Let's do dot exit here. It's clear, and we'll go back into Node, and let's go ahead and do an import on that. So I'm going to do const HTTP is assigned, and let's do a require. And let's go ahead and bring in our HTTP. Okay, perfect. Let's do HTTP, and let's just do methods. So that is a list of all the methods, the HTTP methods that we can potentially listen for from a web client. And so the more common ones that we really talked about previously were the get, it was the delete, it was the update, right? It was the let's see here, is content get, yeah. So this one, we have lock, move, patch, the put, search, the post, and the delete. Those are the 4 big ones. And typically the options one is also one that will get used at times, but you can see there's many more methods than we will actually take advantage of. Let's take a look at the status codes. Status codes represent, so the methods, if you recall, is the message that the web client gives to the web server when it's giving a request. The status codes are something that a web server gives in response to the web client to let them know how what the resolution was, what the response was to that request. And so we already kind of talked briefly about in at least the hundreds category, 100 responses versus 200 versus 300 versus 400. But you can see in very well-defined order here what all these responses that you can issue are, along with their description. such as 418, I'm a teapot. And then we also have the global agent, which is going to point to the agent object. So why don't we just take a look at that. Global agent, and there we go. That's our agent object that we have. And that's just used to manage our connections, persistence, and to reuse HTTP clients. Okay, so let's talk a little bit about the methods that are available in our HTTP module. We have the ability to create a server. And so we actually use this one in the lab that you're currently working on. You have the method to request. So that makes an HTTP request to a server, creating an instance of the HTTP client request class. So this allows us to actually be a web client ourselves. And this is sometimes often required because we might even our backend. So one of the good things to know about building web applications is that your web server can be a web client to some other web service. So we might get a client request that we resolve in our application, our backend application, that request some data from some other service that's hosted remotely. And then we will request that data as essentially a web client. We will get back that response, and then we would give back our response to that web client. And so thinking of breaking our applications down into a collection of HTTP request responses that can be distributed across the application is typically thought of or allows us to start considering a application architecture that's called microservices. Has anyone heard of that before? I hadn't mentioned it before, but that seems to be a really big approach for designing web applications right now. Is a micro architecture model versus a monolithic model. Have any of you guys talked about that in maybe software engineering or any of your other classes? And if not, really what it refers to is instead of designing your application as one big monolithic structure, you break it down into smaller sets of services that operate on on this model here, where you essentially break it down into a collections of modules that are autonomous in and of themselves, and any application can easily just make requests to these smaller modules and then aggregate the pools of data together and then respond back. And so the idea behind a microservice architecture is that it allows you to decouple all of the features that your application needs to provide, so that if you have to bring a part of your system down, you can do it without bringing your entire system down. And in fact, you can actually build your system across multiple platforms and in multiple languages. So if some of your application has to do statistics, maybe you want to do it in Python, whereas another part of your application has to do something that's heavily concurrent, perhaps you want to do it in Go. And so a microservice architecture allows you to actually build a system that's distributed in a way that you can use the best language for each small part of the system as a whole. I'm not going to go into that in much detail. Yeah, I won't go into it in much detail. It is a popular architecture style. Both monolithic and microservice architectures have their own pros and cons, but web-based applications in particular seem to benefit significantly from this concept of microservice architecture because of this concept of being able to issue out HTTP requests and responses, so that we can consume APIs ourselves without having to build everything from the ground up. Anyway, that was more of a non sequitur more than anything, just talking about how our server can be a client to something else. And then we have HTTP Dot Git, which is similar to HTTP request, but it just issues a Git request. So this is a GET request. This builds a request object, and this creates a server. So obviously, the HTTP methods module is really, in terms of its methods, relatively simple. You can either create a web server or you could issue a web request. So serve as a web client. Okay, so let's talk about just these classes in the HTTP module and what their responsibilities are. So we mentioned that there was, I believe I said 5 different classes from the get-go. Was it 5? Yeah, agent, client request, server, server response, and incoming message. So let's just talk about what each of those are. So the agent class, so Node creates a global instance of the HTTP agent class to manage your connections, persistence, and reuse for HTTP clients. So this object makes sure that every request made to the server is queued and a single socket is reused. So essentially that is think of it as the ticket agent or the ticket master for all of the requests that are coming in, so that we can handle them within our application. Okay, then we have the client request object. So a client request object is created when the http.request or the http.get is called, or we can actually construct an instance of that as well when handling a request. So when a response is received, the response event is called within the response. Let me reword that. So when a response is received, we get the response event is called with the response. So we have a client request. This is for the instance that our backend server is the client. So we're sending out a request. We have to handle a response. So the return data of response can be read in 2 ways. You can call the response.read method to read the response that's given back to you from the web server. Or in the response event handler, you can set up an event listener for the data, so you can listen to the data stream as it actually comes in case it's been chunked out. Then you have the server class. So the class is commonly instantiated and returned when creating a new server from the method createServer. And once you have a server object, you have access to these methods: close and listen. Close stops the server from accepting new connections, and listen starts the HTTP server and listens for connections. So I know, for instance, that we go ahead and make use of the server class methods when we make our own web server in Node using the HTTP module. And just an example of the server response. So for server response, it's created by the HTTP server class itself and passed as the second parameter to the request event. And again, this is going to create the server's response message, where it has the ability to get the header names, to get the headers, to be able to set the headers, to be able to remove a header, to check to see if it has a header. So essentially everything that's required for managing a server response is what this class is designed for. An incoming message is really just designed to do a client request. So incoming message represents the client request or the message from a client request versus the server response. Anyway, that is essentially the HTTP module. And so that really represents very briefly what the standard library of the Node environment provides to you.